Alright, in this video we're going to finish up the notes from last week, and we're going to begin with properties of rhombi. Remember, the word rhombi is plural for rhombus. So let's just talk about the 5 characteristics of a parallelogram. We know that opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, and consecutive angles are supplementary, and the diagonals bisect each other. So since a rhombus is a specialized parallelogram, it has all those family traits of a parallelogram, in addition to 3 more. Okay? In a rhombus, we have all sides that are congruent. So you can see from this diagram, we have the markings. The diagonals, if you'll notice here, the diagonals are perpendicular. So they form right angles. So we have a bunch of right triangles in here. And the diagonals bisect the opposite angles. So we know that the diagonals already bisect each other, and in a rhombus they bisect the opposite angle. So now we have angle bisector. So the angles for a rhombus have been bisected. And there's the congruent angles. Alright, so let's take a look at a few examples. And looking at this, try to turn off the video and see if you can answer some of these on your own. I know some of you will and some of you won't, but it'd probably be a good idea to practice these properties. So in the first example, you'll notice that I have marked up this diagram really good before I've even started, just to show all the relationships. Makes it a little bit easier to answer these questions. So XY is 27, because if one side is 27, then all 4 sides are 27. WP, right here, is the same as the other side, which is 21. PZ, which is this length here, is not so easily calculated because we don't know this side here and it's not 21. Notice that all the diagonals are not equal, so their halves are not equal. So what we're going to have to do is clear this out and use this information here. We're looking for this value right here. I called it X. We know that this side is 21 and this side is 27, and we do have a right triangle here, so guess what? Pythagorean's theorem. We're going to have to use Pythagorean's theorem to find this out. The 27 represents C, or the hypotenuse, so make sure you set this up carefully and calculate the answer, and you're going to round this off to the nearest whole number. So it's approximately equal to 17. So keep in mind now that we have right triangles, we have all the properties. We might even use the 30, 60, 90 properties at some point. So be on the lookout. The angles, okay, so this angle is 51 because this is an angle bisector. So these 2 angles are equal and these 2 angles are equal. They all equal each other. And 78, where did I get 78? XWZ, that's this angle right here. This whole thing. Alright, so if this is 51, this is 51, so this whole thing is 102. So this would be the supplement, because consecutive angles are supplementary. So that's where the 78 came from. And then half of that angle is 39. So ZYW is looking at the half of this. Okay. Next, we are given these 2 pieces here. Find the measure of angle FGE, which is this little piece right here. Well, what we know about these 2 angles right here is that they're equal to each other because we have an angle bisector with rhombus. And so we can solve for x, and x is equal to 14. And then if I plug in 14, I get 63. and I'm looking for this piece here, so make sure you mark up what it is you're looking for so you know when you're done. These two angles have to add up to 90 because the three angles add up to 180, and we've already got a 90 degree, so these two have to add up to 90. So your answer is going to be 27 degrees. All right, the next object is our square, and again, just fill in these pieces here. And what a square is actually a square is a rectangle and a square is a rhombus because it shares all those properties. So it's the overlap of both. So it actually has all the properties of a parallelogram, up to diagonals bisector each other, and then the two properties of rectangles, and then the three properties of rhombus. So this one has it all. 10 different relationships. That's a lot. Okay, so if in doubt, the square has it all. Let's take a look at a few examples. Again, we do have right triangles that are formed here because we have right angles here. So just make sure you know your properties. This is going to be 16. Where did 16 come from? Well, this diagonal is equal to this diagonal, and this is 8 and this is 8, so the whole thing is 16. BC, this one is not as easily noted here, folks. You have to use Pythagorean's theorem because you're only given one piece of the puzzle, and that's a diagonal, and that side does not equal this side. So we know that each of these two sides equal 8, and 8, take the square root, is 11.3, so that's approximately. The measure of angle CFD is a right angle, so it's 90 degrees. That was this angle right here. And the measure of angle DBE is this angle here. Well, this is a right angle that's been bisected, so that's going to be 45. So this triangle actually has a host of 45, 45, 90 degree triangles in it. So we could have done this one here by 8 root 2, and 8 times the square root of 2 is going to be 11.3. So that was just a little perk there for you to remember. Okay, and last, if QRST is a square, find QS. All right, so we know it's a square, so it has a ton of properties. Find QS, that's this line right here. And all we're given is this is 21. So that is a right triangle. Both sides are 21. And again, you can use the fact that you have two equal sides, which means you have two equal angles, so these are 45 and 45, x root 2, or you can use Pythagorean's theorem, which is what I did here, because most of you probably won't see that, 45, 45, 90 yet. It's a trained eye thing, so we will just use Pythagorean's theorem and get approximately 29.7. All right. Let's take a look at the summary of this. So in the family of parallelograms, I'm not going to list out all 5 of those attributes because I think we know them by now. But the new ones, the rectangles, the 2 additional pieces that they have are all right angles and congruent diagonals. And then the rhombus have these 3 features: perpendicular diagonals, all sides are congruent and diagonals bisect each other. And the square is both a rectangle and a rhombus. So a square is a rectangle, folks. I know that sounds weird, but it is. It shares all these properties. And it's also a rhombus. Okay? When a rhombus is a rectangle, it's a square. That's the only time a rhombus can be a rectangle, is when the rhombus is a square. I know that sounds confusing, but again, this is the overlap. This is the overlapping piece, and this square has all of these and all of these. So that concludes this video, and now you can work on your assignment.